Well, hi everyone. Let's work on this practice test, test 9, our first trig test. Alright, for 1 and 2, determine the measures of the two coterminal angles, one negative and one positive, for the angles given. So, I'm going to go negative 87 degrees. Just keep in mind, that'd be negative this way. If I get all the way to here, that's negative 90 degrees from this initial side. Some short of negative 90 degrees there. Negative 87 degrees. If I add 360 degrees to it, I'll be coming from the positive side on that. And negative 87 plus 360. I'm getting 273 degrees. That kind of makes sense. I was 3 degrees short at negative 90, so there's 270 and 3 more degrees. And then if I need another negative, I need to start here and just come around again. So I'll go negative 87 degrees minus 360 degrees, going in the clockwise direction. And that would give us negative 447 degrees. So those are two coterminal angles with negative 87 degrees. One's positive, one's negative. We'll do the same thing here, only this time I'm going to use 2 pi instead of 360. So I'm going to add 2 pi, which is 7 pi over 18 plus 36 pi over 18. 7 plus 36, that's 43 pi over 18 radians. And I'm going to subtract 2 pi. 7 pi over 18 minus the 36 pi over 18 is 7 minus 36, negative 29 pi over 18. Okay. Converting negative 210 degrees to radians. I'm going to multiply that by pi over 180 degrees. And that's going to be negative. If I take 30 into both these, 30 goes into both these, I'll get negative 7 pi over 6, and the degrees are canceling out, so that's radians there. Now 5 pi over 6, if I multiply that to convert to degrees, this time 180 degrees over pi, my pi's will cancel out. I'm actually going to go divide these by 6, and that's 30, so we're talking 150 degrees here. Okay. 271.35 degrees to degrees, minutes, seconds. So the first thing I'm going to take the fraction part, 0.35, and multiply it by, what I'm multiplying it by is 60 minutes per degree. So, and that gives me 0.35 times 60 gives me 21. Okay, and there's no fraction part, so that's 0 seconds. So I'm going to go 271 degrees, 21 minutes. Now this time, I'm going to convert 11 seconds into minutes, and then add that on to the 20 minutes, and convert that minutes into degrees. So 11 divided by 60 I'm going to go is 0.183 repeating. So I'm going to take now that's minutes now. I'm going to add it to the 20 minutes and get 20.183, and at this point approximating. So add 20 to that, and I will divide that by 60. 0.336. Oh, thousand. Okay, read the directions. 0.3364. Oh, thousands, that's just 3. So 0.336 is fine. All right, so that's degrees. So it's 38.336 degrees. Now 7, we're going to find the length of this arc, the dark part here, to the nearest hundredth. Okay, remember arc length is S equals R theta. Now theta has to be in radians. So that arc length S is equal to 11 feet times, I'm going to just do it within the problem here, 315 degrees times pi over 180 degrees. And we're rounding the nearest hundredth, so I'm just going to plug it all into the calculator. 11 times 315 times pi divided by 180 gives me nearest hundredth 60.48. And do get your, it's arc length, that's just a linear measurement, that's feet, 60.48 feet. Now, this one says find the exact length, which I'm going to, pi will probably be, it'd be a multiple of pi. And S is R times theta again. And we want to know this length right here, because that's the angle they designated. And that arc length is 19 times 150 degrees times pi over 180 degrees. I'm going to simplify a little bit. 15, I'll divide by 10 and then divide by 3. And that's 5 and that's 6. So 19 times 5 is 95 pi over 6. Okay, if I just plug pi into the calculator, I go to approximating instead of having exact. So I'm going to leave it like this as my exact answer. And that's in feet. And I'm going to remember to put units in. Units count, guys. Now, number 9, the area of this sector right here. We're going to find the area of that. Okay, area is 1/2 r squared theta. So, theta has still got to be in radians. So I'm going to take 1/2 times 16 squared times 240 degrees times pi over 180 degrees to get that converted to radians. And it says nearest hundredth, so I'm just going to plug it all in. 0.5 times 16 squared times 240 times pi divided by 180 is, all right. Oh, okay. I have a division there. I wanted to times. This looked way too small. This threw me off. So second entry, let me change. Right there, that's a times. Okay. 536.17. And we have square feet. It is a sector area. All right. Right here we have an application. A sprinkler on a golf green is set to spray water over a distance of 40 feet and rotate at an angle through an angle of 170 degrees. Alright, so I'm going to draw a circle. Here's the sprinkler in the middle of the circle. It points to this side over, that's 180, so I'll just go up here a little bit and say this is 170 degrees. So we want to know this area. And we're going to take 1/2 times 40 squared times 170 degrees times pi over 180 degrees. I think I can just change a few numbers in the last. So if I hit second and enter, I've got the last equation that I put in. 0.5 times, I'll put 40 here, and I'll put 170 here, and everything else is the same. So we're talking about 2,373.65 square feet. All right. 11. Give the measure in degrees of the central angle that intercepts a 5.7, and it's in degrees. Let's make sure we're looking at that. 5.7 centimeter arc, whose radius is 10. So I'll put the radius here is 10. 5.7, let's go up about like this. Okay, and we're looking for that theta. This is 5.7. S equals r theta. R is 10. S is 5.7. Theta, divide by 10. We get theta is 0.57 radians. I'm going to multiply that by 180 degrees over pi. I know radians will cancel out with radians here. So I'm going to take 0.57 times 180 divided by pi. And I'm saying that is approximately, and that seems reasonable, 32.66 degrees. Okay, number 12. A carousel with a 50-foot diameter makes 4 revolutions per minute. Okay? Find the angular speed in radians per minute. So let's remember that we go 2 pi radians per revolution. If we're going to angular speed, this is probably something we're going to be using. If I multiply that by 4 revolutions per minute, the revolutions are going to cancel out, and it's going 8 pi radians per minute. Okay, now the linear speed, we're going to go circumference is per revolution. In this case, circumference in the feet per revolution. So, and we're going to change it to miles per hour, but for right now, the circumference is, it's 50 feet diameter, so 50 pi, that's the circumference, and that is feet per revolution. I am going to multiply that by 4 revolutions per minute. Okay, now I have feet per minute, but we want miles per hour. let's remember that there are 5,280 feet per mile. Also, there are 60 minutes per hour. Okay, so I need my minutes to cancel out. So I'm going to multiply this by 60 minutes per hour. Now I've got, now I've got feet per hour. Now I need my feet to cancel out, and miles will be on the top, so I'm going to go 1 over 5,280 for this last conversion of a mile per foot. And the feet will cancel out, and it'll be miles per hour. So let's just do that calculation here. 50 times pi times 4 times 60. I'm going to go, you could times by 1 over 5,280. I'm going to just, that's the same as dividing by 5,280. And that is 7, that's about 7.14 miles per hour. All right, sketch a right triangle corresponding to cotangent theta is equal to 7 over 2. All right. And I'm going to put theta right here. And cotangent is adjacent over opposite. Tangent is opposite over adjacent. So adjacent is 7, opposite's 2. Notice I didn't get it by scale there, did I? All right, and then my hypotenuse. This is adjacent. This is opposite. And this is hypotenuse. And I'm going to use Pythagorean theorem. Get 2 squared plus 7 squared equals c squared. That's 4 and 49 equals c squared. 53 is c squared. So square root of 53 is c. And the sine of theta is opposite 2 over hypotenuse, square root of 53. So I'll multiply that by the square root of 53 over the square root of 53. So that's 2 radical 53 over 53. The cosine of theta is 7 over the square root of 53. It's the adjacent over the hypotenuse. And I'll times that again by square root of 53 over square root of 53. And I'm getting 7 radical 53 over 53. The tangent of theta is 2 over 7. The cosecant of theta is the reciprocal of sine. So I would take the square root of 53 over 2. The secant of theta, which is the reciprocal of cosine, would be the square root of 53 over 7. And we already had that the cotangent of theta is equal to 7/2. Okay. Now number 15. I'm going to do a cross-section of the Earth here again along this parallel that Boise and Las Vegas lie on. Okay, so here's the equator. There's the center of the Earth. Boise is 43 degrees, so I'm going to draw Boise right here. Las Vegas is 36 degrees. I'm going to draw Las Vegas right here. I'll put theta right here, and we're going to find that arc length. Okay. So let's take, to find theta, let's take 43 degrees, 36 minutes, 54 seconds, minus 36 degrees, 10 minutes, 12 seconds. Alright, time for the conversion. 54 divided by 60 is 0.9. 36.9 divided by 60 is 0.615. 43.615 minus 12 divided by 60 is 0.2. 10.2 divided by 60 is 0.17. 36.17. These are degrees now. We've got them in decimal degrees. So let's take 43.615 minus 36.17. I get 7.445 degrees. Now, to use the S equals R theta, I need to change that to radians. And we are approximating here. So I don't need it as a multiple of pi. So I'm going to take 7.445 times pi and divide that by 180. And I'm just going to go with, that is about 0.13. That's very close to 0.13 radians. Now, this distance is, okay, 4,000 miles times 0.13 radians. That'll be the number of miles. So I'm going to multiply that by 4,000. And I'm going to go 519.8 miles. It's approximately 519.8 miles from Boise to Las Vegas. All right. Number 16. From the top of a spire of height 50 feet, the angles of depression of two cars on a straight road at the same level as that of the base of the spire on the same side of it are 25 degrees and 40 degrees. Okay. So we have like a church here. Okay, I'm not going to draw. Okay, here's the top of the spire, and that's 50 feet. Now, you've got an angle of depression. This is the smaller angle. This is the 25 degree. This is the 40 degree. From the top, this is 50 feet. Okay, so this is, I'm going to solve for this side here first. And when I do that, this is opposite and this is adjacent. Just figure out how far this one is from the church, and then we can probably just figure out how far that one is, and then subtract the two amounts. So let's go, the tangent of 40 degrees is equal to 50 over x. Okay, if I multiply both sides by x, I got x times the tangent of 40 degrees is equal to 50. And then if I divide both sides by the tangent of 40 degrees, I'll get my x value. So x is equal to 5 divided by the tangent of 40. Let's see if this is reasonable. So I get an x to be about 5.96 feet. Wait. Okay. All right. Opposite over adjacent. All right. That just doesn't seem like very much to me. Oh, it's not 5, it's 50. Okay. Oops. Okay. All right. I've been better off just typing it in. 59.59. Okay. So that is 59.59 feet. All right, and then the 25 degrees, these are pretty big angles, so that's why we're not getting enormous numbers here. The 25 degrees, this is, I just call this y from here to here. And I'm going to take y minus x, and that's going to give me our distance. So that's the tangent of 25 degrees equals 50 over x. And times that by x. And I got x times tangent of 25 degrees equals 50. I'll divide by tangent of 25 degrees. I'll just change the 40 here to 25. I get 107.22. Oh, these are y's. Get my variable. So y is 107.23 feet. And then I'm going to take the 107.23 feet minus 59.59 feet. I get 47.64 feet. That's how far right here the two cars are apart. All right, there we go. You guys take care.